I want you to stop for a moment. Right now, whatever you were doing, wherever you are, just stop. You feel time passing, don't you? You feel the present moment, the now, this specific, irreplaceable instant in which you are experiencing this video. And a second ago, there was a past, and a second from now, there will be a future. This feels so obvious it barely seems worth saying. Of course time is passing. Of course the present is real. Of course yesterday is gone, and tomorrow hasn't happened yet. You are as certain of this as you are certain of anything. And you are wrong. Not a little wrong. Not wrong in some abstract philosophical sense that doesn't affect your daily life. Wrong in the most fundamental, most physical, most mathematically precise way possible. According to our best and most tested theories of physics, time as you experience it does not exist. The present moment is not special. The past is not gone. The future is not unwritten. Every moment that has ever existed and every moment that will ever exist exists right now, simultaneously, equally real, equally present. Your birth is happening right now. Your death is happening right now. Every conversation you have ever had, every meal you have ever eaten, every sunrise you have ever watched, they are all happening simultaneously in a universe where the word now has no meaning. This is not a metaphor. This is not poetry. This is what physicists actually believe based on the mathematics of our most successful theories. The feeling of time passing, the sense that the present is special, the certainty that the future is open and the past is closed, all of it is a trick, a construct of consciousness, a story your brain tells you about a universe that does not work the way your brain thinks it does. And the strangest part? We do not fully understand why. We do not know why time feels like it flows when the equations say it doesn't. We do not know why we remember the past and not the future. We do not know what the present moment actually is, or if it exists at all. Welcome. Today, we are going to dismantle the thing you are most certain about. We are going to take time apart, piece by piece, and show you what physics actually says is underneath. And what is underneath is stranger, more beautiful, and more terrifying than anything you were taught in school. Time does not exist, and once you understand why, you will never experience a single moment the same way again. Let's start from the beginning. What is time? It seems like a simple question. Time is what clocks measure. Time is what passes while you wait. Time is the thing that separates before from after. But push on this even slightly, and it starts to get strange very quickly. The ancient Greeks had two different words for time: chronos, which meant linear clock time, the measurable sequence of moments, and kairos, which meant the right moment, the opportune instant, time as experienced rather than measured. That distinction between time as measurement and time as experience turns out to be one of the most important in all of physics. For most of human history, we assumed these two things were the same, that the clock on the wall was measuring the same thing we were feeling, that the ticking of seconds corresponded directly to the flow of experience. Newton believed this completely. In his framework, time was absolute, universal, a backdrop against which everything happened. Newton imagined time as a great river flowing at the same rate everywhere, indifferent to anything happening within it. Every clock in the universe, no matter where it was, would tick at exactly the same rate. Two observers, no matter how fast they were moving relative to each other, would always agree on what time it was. Time was the one fixed, reliable, universal constant. This felt obviously correct. It matched every human experience. It matched every observation anyone had ever made. And it was completely wrong. In 1905, A 26-year-old patent clerk in Bern, Switzerland, published a paper that would shatter Newton's absolute time forever. His name was Albert Einstein, and his paper on special relativity began with a simple observation that had enormous consequences. The speed of light is the same for all observers. That sounds harmless, even boring, but think about what it actually means. Suppose you are standing still and a train passes you going 100 miles per hour. A ball rolls along the floor of the train at 10 miles per hour. From your perspective, the ball is moving at 110 miles per hour. Simple addition. This is how speeds work. Now suppose instead of a ball, a beam of light is sent from the front of the train. How fast is it moving from your perspective? You might expect 100 miles per hour plus the speed of light, the train's speed plus the light's speed. But that is not what happens. The light moves at exactly the speed of light, not a hair faster. The train speed adds nothing. Einstein realized that the only way this could be true is if something else was changing. If speeds can't add up for light the way they add up for everything else, something about the measurement of speed must be different for different observers. And speed is just distance divided by time. If speed doesn't add up the usual way, it means distance and time are not the same for all observers. Two observers moving relative to each other do not measure the same distances, and they do not measure the same times. This is called time dilation, and it is not an illusion, it is not a measurement error, it is physically real. A clock on a moving train ticks slower than a clock that is stationary, not slightly slower in some approximate sense, actually, genuinely, measurably slower. The faster you move, the slower your clock ticks relative to a stationary observer. This has been confirmed countless times. We put atomic clocks on airplanes and compare them to clocks on the ground. The airborne clocks tick slower. GPS satellites have to correct for this effect continuously, or your navigation would be wrong by miles every day. Time is not universal. Time is not absolute. Time is not the same for everyone. How much time has passed depends on how fast you have been moving. And that single fact, once you follow it all the way to its logical conclusion, leads somewhere most people are not prepared to go. It leads to the death of the present moment. Because if time flows at different rates for different observers, then there is no single universal now. There is no global present. There is no moment that is simultaneously now for everyone, everywhere. Your now and my now, if we are moving relative to each other, are not the same now. And when you scale that up to cosmic distances, to galaxies separated by billions of light years moving relative to each other at different velocities, the concept of a universal present becomes not just uncertain, but meaningless. The present is not a universal feature of reality, it is a local experience. And local experiences in physics are not the bedrock of truth. Now I want to introduce you to the idea that physicists believe most seriously resolves the puzzle of time. It is called the block universe, or sometimes eternalism. And it is, without question, one of the most disturbing ideas in all of science. Here is the core claim. The universe is not a three-dimensional space in which time flows. The universe is a four-dimensional block, a static, unchanging structure in which every event that has ever happened or will ever happen already exists. Past, present, future, all equally real, all equally existing, all equally there. Nothing is created when the future becomes the present. Nothing is destroyed when the present becomes the past. Events do not pop into existence and then fade away. They are simply there, fixed in the four-dimensional structure of space-time, forever. Your birth exists in the block, permanently, unchangingly, right now. Your death exists in the block, permanently, unchangingly, right now. Every moment of your life exists simultaneously in this four-dimensional structure. The block does not change. It does not evolve. It simply is. What we experience as time passing is not the block changing. It is our consciousness moving through the block, like a spotlight moving across a stage, illuminating one spot at a time, creating the illusion that only the illuminated spot exists. But the rest of the stage is still there. It was always there. It will always be there. Einstein himself believed this deeply. In a letter written near the end of his life to the family of his recently deceased friend Mikhail Besso, Einstein wrote that the distinction between past, present, and future is only a stubbornly persistent illusion. He meant this literally. The mathematics of relativity makes the block universe almost inevitable. Here is why. Remember what we said about simultaneity. Different observers moving at different velocities disagree about what events are happening at the same time. Suppose you and I are moving relative to each other. I say two events happened simultaneously, you say one happened before the other. Who is right? According to relativity, we are both right. There is no fact of the matter about which is correct. There is no universal now that settles the dispute. But here is the strange consequence. Suppose you say that event A happens before event B in your frame of reference. In my frame of reference, moving relative to you, event B might be happening right now, simultaneously with this moment in my experience. That means event B is present for me. It is happening now in my experience. But event B is in your future. It hasn't happened yet for you. If event B is real enough to be my present, how can it not be real? How can something be simultaneously present for one observer and non-existent for another? The only way to resolve this is to say that event B exists, that it is real, that it is there in the four-dimensional structure of space-time, whether or not any particular observer has reached it yet. The future is real. It is already there. We just haven't reached it yet. This argument is called the Reitdijk-Putnam argument, developed independently by two philosophers in the 1960s. It shows that the relativity of simultaneity almost forces you to accept the block universe. If you take relativity seriously, and we have overwhelming experimental evidence that we should, you are almost forced to conclude that the future already exists. And if the future already exists, then free will, as we normally understand it, has a problem. If your future choices already exist in the block, if the decision you will make tomorrow is already there, fixed and unchanging in the four-dimensional structure of reality, in what sense did you freely make that choice? This is not a new philosophical puzzle. Free will has been debated for millennia, but the block universe gives it a very specific and very physical form. It is not just that God knows what you will do, it is that the laws of physics, as we currently understand them, imply that what you will do already exists as a physical fact in the structure of space-time. The future is written, it just hasn't been read yet. Okay, so we have established that the equations of physics treat time very differently from how we experience it. The block universe says past and future are equally real. Relativity says there is no universal present. But here is the thing that makes this even stranger. Almost all of the fundamental equations of physics work equally well in both directions of time. Let me say that again. The equations that govern how particles interact, how gravity works, how electromagnetism operates, almost all of them have the same form whether time is going forward or backward. If you filmed a collision between two billiard balls and ran the film backward, the reversed collision would be perfectly consistent with the laws of physics. There is nothing in the equations of particle physics that distinguishes past from future. If you filmed two electrons interacting and ran it backward, the reversed interaction would be physically valid. The laws do not care which direction time is flowing. But this creates an enormous puzzle, because we obviously experience time as flowing in one direction. We remember the past and not the future. We can influence the future, but not the past. Eggs break, but do not spontaneously reassemble. People age and do not de-age. Ice melts in warm water, but does not spontaneously refreeze. If the fundamental laws are time-symmetric, if they work equally well in both directions, why does time have a direction in our experience? This question is called the problem of the arrow of time, and it is one of the deepest unsolved problems in physics. The best answer we have involves entropy. Entropy is, roughly speaking, a measure of disorder, a measure of how many possible arrangements a system could be in while still looking the same from the outside. A hot cup of coffee in a cold room has low entropy. The heat is concentrated in the cup. There are relatively few ways to arrange the energy to achieve this. Over time, the heat spreads out. The coffee cools. The room warms slightly. The energy becomes evenly distributed. This is a high entropy state. There are enormously many ways to arrange the energy to achieve this even distribution. Systems naturally move from low entropy to high entropy, from ordered to disordered, from concentrated to spread out. This is the second law of thermodynamics, and it is the only major law of physics that is not time-symmetric. It only works in one direction. Entropy increases toward the future, not toward the past. So the arrow of time, the reason time seems to flow in one direction, is tied to the second law of thermodynamics. Time flows in the direction that entropy increases. But this immediately raises a deeper question. Why did entropy start low? For entropy to be increasing now, it must have started in a very low state. The universe must have begun in an extraordinarily ordered, low entropy condition for entropy to have been increasing ever since. And it did. The Big Bang was an extraordinarily low entropy state. The early universe was almost perfectly smooth and uniform, almost perfectly ordered. The structure we see today, the galaxies and stars and planets and people, all of it is the result of entropy increasing from that initial low state. But why did the universe begin in such a low entropy state? Why was the Big Bang so extraordinarily ordered? We don't know. This is sometimes called the past hypothesis, the assumption that the early universe had very low entropy. We need this assumption to explain why time has a direction, but we cannot derive it from anything deeper. It is just a fact about our universe that we observe but cannot yet explain. Some physicists, like Sean Carroll, argue that the arrow of time is the single most important unsolved problem in fundamental physics, because without understanding it, we do not understand why we remember the past, why causes precede effects, or why time feels like it flows at all. Everything about our experience of time, every feature of what it feels like to live in time, depends on this fact about entropy that we cannot explain. The arrow of time, in other words, might be an accident, a consequence of a cosmic coincidence, an artifact of the particular low entropy state in which our universe happened to begin. In a universe that began in a high entropy state, if such a thing is possible, time might feel like it flows in the opposite direction, or it might not feel like it flows at all. Everything we have talked about so far comes from relativity, but there is another branch of physics, equally successful, equally strange, that has its own radical things to say about time. Quantum mechanics. Quantum mechanics is the theory that describes how the very small works: atoms, electrons, photons, quarks. It is the most precisely tested theory in the history of science. Its predictions have been confirmed to more decimal places than any other theory ever proposed, and it has a deeply uncomfortable relationship with time. In quantum mechanics, there is an equation called the Schrödinger equation. It describes how quantum systems evolve over time, and like the equations of classical physics, it is completely time-symmetric. Run it forward or backward, it works the same way. There is no arrow of time in the Schrödinger equation. But quantum mechanics also has something that classical physics does not: the measurement problem. In quantum mechanics, before you measure a particle, it does not have a definite position or a definite momentum. It exists in a superposition of many possible states simultaneously. It is, in a meaningful sense, in many places at once. When you measure it, the superposition collapses. The particle suddenly has a definite position. It is in one specific place. This collapse seems to happen in one direction only. Before the measurement, superposition. After the measurement, definite state. This is irreversible, and irreversibility suggests an arrow of time. But the collapse is not described by the Schrödinger equation. It seems to be a separate process that happens when quantum systems interact with classical measuring devices, and nobody fully agrees on what this process actually is, or why it happens, or whether it happens at all. This is the measurement problem. It has been debated since the 1920s. There are many interpretations of quantum mechanics, and they disagree fundamentally about what happens when you measure a particle. The Copenhagen interpretation, the oldest and still most widely taught, says the wave function simply collapses, and we should not ask what happened before the measurement. It treats the collapse as a fundamental feature of reality. The many worlds interpretation, developed by Hugh Everett in 1957, says there is no collapse. The wave function never collapses. Instead, at every quantum measurement, the universe branches. Every possible outcome of the measurement actually happens in a different branch of reality. In the many worlds interpretation, time is not a simple linear sequence. It is a branching tree. An enormous tree with branches splitting off at every quantum event, billions of times per second in every atom in the universe. Every outcome that can happen does happen in some branch of this enormous branching structure. Your life is not a single timeline. It is a vast tree of possibilities, all equally real, all branching away from each other in the four-dimensional structure of space-time. But here is what is most interesting for our story today. There is a version of quantum gravity called the Wheeler-de Wit equation, which tries to describe the quantum state of the entire universe. And when you write down the Wheeler-de Wit equation, something remarkable happens. Time disappears. The equation has no time variable. It describes the universe as a static, timeless object, a fixed quantum state that simply is, without evolving, without changing, without any reference to past or future. This is called the problem of time in quantum gravity, and it is one of the most profound puzzles at the frontier of physics. If we take the Wheeler-de Wit equation seriously, the universe, at the most fundamental level, has no time. Time is not a fundamental feature of reality. It is something that emerges, somehow, from a timeless underlying structure. Julian Barbour, a British physicist, has developed this idea into a radical proposal. He argues that time does not exist at all, even approximately. What we call time is really just the comparison of different configurations of the universe. The universe does not evolve through time. The universe is a collection of static configurations, what Barber calls nows, and our experience of time passing is the experience of moving from one now to another. But there is no objective ordering of these nows, no fact of the matter about which now comes before which, no arrow, no flow, just a collection of static configurations, all equally real, and consciousness creating the experience of sequence from within. Time, in Barber's view, is fundamentally an illusion. Not approximately an illusion, not an illusion that breaks down at extreme conditions, fundamentally, all the way down, an illusion. All right, so the physics is clear, or at least clearly pointing in a strange direction. Time is not fundamental. The present is not universal. The past and future are equally real in the block universe. The deepest equations have no time variable. But here's the question that I think matters most. If time does not exist, why does it feel so real? Why do we experience duration? Why does waiting feel different from not waiting? Why does a minute of pain feel longer than a minute of joy? Why do we have memories of the past and not the future? Why, in a timeless universe, does time feel like the most real thing there is? This is where physics gives way to neuroscience and philosophy, and the answers are fascinating. Your brain constructs your experience of time. It is not passively receiving a time signal from the universe. It is actively building the experience of duration from a variety of inputs. Consider what happens when you catch a ball. Your hand moves to intercept the ball before it arrives. Your brain has predicted where the ball will be and has already sent motor signals to move your hand. All of this happens before you are consciously aware of the ball. Consciousness, it turns out, is always slightly in the past. By the time you are aware of something, your brain has already processed it, already responded to it, already made decisions based on it. Your conscious awareness is a reconstruction, slightly after the fact, of what your brain has already dealt with. The neuroscientist Benjamin Libet famously showed that the brain activity associated with a voluntary movement begins several hundred milliseconds before the conscious intention to move. Your brain decided to move before you consciously decided to move. The implications of this are still being debated. Some interpret it as evidence against free will. Others argue the conscious veto, the ability to stop an action after the brain has initiated it, preserves a form of freedom. But either way, the picture of time that emerges is strange. The now that you experience is not the actual present moment of the universe. It is a construction, a story your brain tells you, slightly delayed, edited for coherence, stitched together from sensory inputs that themselves took time to arrive. Your experience of now is always a moment ago, and the experience of time flowing, the sense that moments are arriving and departing, may itself be a construction. Philosopher Daniel Dennett argues that the sensation of the flow of time is a kind of useful fiction the brain maintains, not a direct perception of something in the world, but an interpretation, a model, a story. When we are bored, time seems to slow down. When we are engaged, time flies. When we are in extreme danger, some people report time seeming to stop, with great clarity and slowness. None of these experiences correspond to anything happening to objective time. They correspond to changes in how the brain is processing information. Under stress or excitement, the brain processes more information per unit of objective time. More information processed means more subjective time experienced. The world seems to slow down because you are perceiving it in a greater detail. Time is not something you perceive, it is something you construct. And if time is constructed by the brain, And if different brains constructed differently under different conditions, what exactly is the time that physics is trying to describe? Is physics describing the objective flow of the universe, or is it describing the parameters that shape the brain's time construction? These are not questions with clean answers. They are at the boundary of physics, neuroscience, and philosophy, and they remain genuinely open. But they point towards something that I find profoundly interesting. The time you experience is not the time the universe has. Your subjective now is not the objective now. And if there is no objective now in physics anyway, then the time you live in is a creation, a beautiful, seamless, completely convincing creation, but a creation nonetheless. There is something else that makes the puzzle of time even deeper. Memory. You remember the past, not the future. This seems obvious, but in a universe where the fundamental laws are time-symmetric, why should memory work in only one direction? A camera records what happened. It doesn't record what will happen. Why? The answer again comes back to entropy. For a record to exist, something must have changed. A camera takes a photograph by having light change the chemistry of film or the charge of pixels. A memory forms by having experience change the physical structure of the brain, creating new synaptic connections. For a record to be made, entropy must increase. Information must be written into a physical system, and writing increases disorder. Records, therefore, only exist in the direction of increasing entropy, which is, as we established, the future direction. So we remember the past because the past is the low entropy direction. We cannot remember the future because the future is the high entropy direction, and records require entropy to have already increased. This means memory, causality, and the arrow of time are all the same phenomenon. They are all consequences of the fact that our universe began in an extraordinarily low entropy state. Cause comes before effect because entropy increases in the direction we call future. Memory records the past because the past is the low entropy direction. If entropy were decreasing, if somehow we were in a universe where disorder was spontaneously turning into order, which is not impossible in principle, just fantastically unlikely in practice, then cause would come after effect. Memory would record the future. Time would feel like it flows in what we would call the opposite direction. Some physicists have suggested that there may be regions of the universe or other universes in a multiverse where entropy decreases rather than increases. Beings living in those regions would experience time as flowing backward from our perspective. But from their perspective, they would be living normally, with cause before effect and memory of the past. There is no objective direction of time. There is only the direction that entropy increases, and that direction is what we call the future. Now, here is something that should genuinely disturb you. The laws of physics do not forbid the past from being influenced by the future. I know that sounds impossible. Everything we experience suggests that causes precede effects. You cannot change what has already happened. But in quantum mechanics, there are experiments where the results seem to depend on choices made after the measurement. The quantum eraser experiment shows that whether you observe which path a photon took can apparently affect what pattern you see in the interference, even if the choice is made after the photon has already passed. Richard Feynman's path integral formulation of quantum mechanics, one of the most powerful tools in all of physics, explicitly treats particles as traveling backward and forward in time. Antimatter is mathematically equivalent to ordinary matter moving backward in time. This is not metaphor. This is how the calculations work. John Wheeler proposed what he called a participatory universe, in which observers in the present can, through quantum mechanical choices, affect what happened in the past. Not change it exactly, but participate in creating it. The boundary between past and future in quantum mechanics is blurrier than our experience suggests. Causality, the principle that causes precede effects, may be less fundamental than we think. It may be another emergent feature, another consequence of entropy and our position in the block universe, rather than a fundamental law of nature. We have been talking mostly about well-established physics, relativity, quantum mechanics, thermodynamics. Now I want to take you to the frontier, to the places where physicists are actively trying to reconcile these theories and finding something extraordinary. The two great pillars of modern physics are general relativity and quantum mechanics. Relativity describes the very large, gravity, space-time, the universe at cosmic scales. Quantum mechanics describes the very small, atoms, particles, the universe at subatomic scales. Both theories are extraordinarily successful, both are confirmed by experiment to stunning precision, and they are fundamentally incompatible with each other. The mathematics of general relativity breaks down at the quantum scale. The mathematics of quantum mechanics cannot handle gravity. When you try to combine them, you get nonsensical infinities. The calculation gives you answers like infinity, which in physics means the theory is breaking down. Resolving this incompatibility is the central challenge of modern theoretical physics. It is sometimes called the search for quantum gravity, and there are several competing approaches. String theory is the most famous. It proposes that all fundamental particles are not points, but tiny vibrating strings of energy. Different vibrational modes of the string correspond to different particles. The theory requires extra spatial dimensions beyond the three we experience. Loop quantum mechanics takes a different approach. Instead of modifying the description of matter, it modifies the description of spacetime itself. In loop quantum mechanics, spacetime is not continuous. It has a granular structure at extremely small scales. The smallest possible unit of area is about 10 to the power of minus 66 square centimeters. The smallest possible unit of volume is about 10 to the power of minus 99 cubic centimeters. Space, at the most fundamental level, is not smooth. It is made of discrete chunks. It has a smallest possible size below which the concept of space breaks down. And time? In loop quantum gravity, time is also discrete. There is a smallest possible unit of time, called the Planck time. It is approximately 5 times 10 to the power of minus 44 seconds. Below this scale, time itself loses meaning. But loop quantum gravity does more than just discretize time. In many versions of the theory, time completely disappears at the fundamental level. The Wheeler-DeWitt equation, which we mentioned earlier, has no time variable, and loop quantum gravity must find ways to recover time as an emergent phenomenon from a timeless underlying structure. Carlo Rovelli, one of the founders of loop quantum gravity, has written extensively about what this means. In his view, time is relational. Time is not something that exists on its own. Time only exists in the relationship between physical systems. There is no time in the abstract. There is only the time of this clock relative to that clock, the time of this heartbeat relative to that rotation of the Earth. When Rovelli writes about time in his beautiful book, The Order of Time, he describes a universe from which time has been subtracted, a universe reduced to relations, to interactions, to events. And what emerges is not a flowing river, but a network, events connected to other events. No global clock, no universal now, just relations. This is profoundly different from our experience. Our experience gives us a clear, linear, directed sequence of moments, a river with a definite direction of flow. Ravelli's universe gives us something more like a network without a preferred direction, more like a web than a river. And the river-like experience of time is something we generate from within the web because of the particular structure of our brains and our thermodynamic environment. We are, in this picture, time-generating machines in a timeless universe. Our consciousness imposes a timeline on a reality that has no timeline of its own. Now I want to take the concept of time even further, because if the block universe is right, if every moment exists equally and simultaneously, then what does that say about the scope of reality? Let's start with the many worlds interpretation of quantum mechanics that we mentioned earlier. In many worlds, every quantum event causes the universe to branch. Every possible outcome of every quantum measurement actually occurs in a different branch of the wave function. The universe is not a single timeline. It is an enormous, constantly branching tree of timelines. In one branch, the coin landed heads. In another, tails. In one branch, you decided to watch this video. In another, you decided to do something else. In one branch, a particular radioactive atom decayed at a particular moment. In another branch of reality, it didn't. This branching is happening billions of times per second in every atom of every object in the universe. The number of branches is incomprehensibly large, and each branch is equally real. In the block universe version of many worlds, all of these branches exist simultaneously in the four-dimensional block. They are all equally there, equally real, equally present. You, in this specific branch, moving through the block along this specific timeline, are just one of an unimaginably large number of versions of you, all equally real, all moving through their own timelines in the block. Some of those other versions of you made different choices. Some live in worlds where history went differently. Some are living through scenarios that seem miraculous or catastrophic from your perspective. All of them are real. All of them exist. All of them are, in some sense, you. Now combine this with the cosmological multiverse, the idea arising from inflationary cosmology that our universe is just one of an enormous number of universes, each with its own physical constants, each with its own history, each having begun from its own quantum fluctuation in an eternal inflating background. Some of these universes may have different values for the fundamental constants, different strengths of gravity, different masses for electrons, different rates of nuclear fusion. Most configurations of constants would not allow stars to form, or planets, or complex chemistry, or life. We find ourselves in a universe that allows all of these things because only universes that allow them can be observed by anyone. In the block universe of this vast multiverse, all of these universes exist simultaneously. All of them are equally real. All of them are there. The question of how many realities exist and what it means for something to be real becomes enormously complex. Max Tegmark, a physicist at MIT, has proposed what he calls the mathematical multiverse hypothesis. He argues that every mathematically consistent structure exists, not just physically, but actually. The universe we live in is one mathematical structure among an infinite number of mathematical structures, all of which are equally real. In Tegmark's view, existence and mathematical consistency are the same thing. If it can be mathematically described without contradiction, it exists. The implications for time are dizzying. If every mathematically consistent universe exists, then there are universes with time flowing forward, backward, sideways, in circles, in branching trees, and not at all. There are universes with completely different conceptions of before and after. Time, in Tegmark's multiverse, is not a fundamental feature of reality. It is a parameter of some mathematical structures and not others. Our experience of time is the experience of living inside a mathematical structure that happens to have a time-like parameter that entropy increases along. We are inhabitants of a particular mathematical universe, one that includes something called time. But the broader reality, the space of all mathematical structures, is timeless. It simply is. I want to stop the physics for a moment and just sit with what we have established. The present moment is not special. The laws of physics do not single it out. Relativity says different observers have different presents. The Bloch universe says all moments exist equally. The Wheeler-DeWitt equation has no time variable at all. The flow of time is not a feature of the universe, it is a feature of consciousness moving through the universe. Or, more precisely, of consciousness constructing the experience of movement through a static structure. The past is not gone, the future is not unwritten. They exist in the block, equally real, equally present, equally there. Your grandmother as a young woman exists right now, not in memory, not in photographs, in the actual physical structure of the four-dimensional block universe. Her younger self exists, equally real as she existed when she was alive. Every person who has ever died still exists in the block. Every moment they lived is preserved, unchanging in the structure of space-time. The block does not forget. The block does not decay. Every moment is permanently, indestructibly there. If that sounds like a kind of immortality, it is, but it is not the immortality of experience. The moments exist, but they do not experience themselves as still existing. They simply are, static, fixed, real. And every moment of your own life is similarly preserved. The moment you learned to walk is still there. The moment you had your heart broken for the first time is still there. The worst day of your life is still there, permanently inscribed in the block, unchangeable and real. But so is the best day of your life. So is the moment you laughed so hard you cried. So is every moment of love you have ever given or received. None of it is lost. All of it is permanently real. There is something profoundly comforting about this, and something profoundly disturbing. Comforting because nothing is truly lost. Every moment that was good, every connection that was real, every experience that mattered is preserved forever in the fabric of reality. Disturbing because every moment that was terrible is also preserved. Every mistake, every loss, every moment of suffering, they are not over. They exist eternally in the block. But perhaps the most interesting question is this. If all moments exist equally, if the block does not change, then what is the you that is moving through the block? What is consciousness in a timeless universe? One possibility is that consciousness is itself a block universe phenomenon, that there is no moving spotlight, that different versions of you exist at different locations in the block, each experiencing their own moment, and the apparent flow of experience is an illusion generated by the structure of memory within the block. You do not move through time, you exist at a location in time, and the version of you that exists at this location has memories of earlier locations, which creates the feeling of having moved here from there. But you have not moved. You are here. Other versions of you are there. No one is going anywhere. The experience of being alive in this picture is not a journey through time. It is the experience of being a particular location in a four-dimensional block, a location that has the information content of a history stored as memories, creating the illusion of having traveled here. You are not a traveler in time, you are a resident of a moment that contains the memories of other moments. Let's get very specific about one thing. Does the past still exist? In everyday experience, the answer seems obviously no. The past is over, gone, done. You cannot visit it, you cannot change it. The people who lived in it are dead. The events that happened in it are finished. But the block universe says something different. The block universe says the past is not gone. It is there, at its location in the four-dimensional block, unchanged, unchangeable, permanent. Ancient Rome still exists, not as a memory, not as an archaeological record, as a physical reality at its location in the block. The events that happened there are happening right now at their coordinates in space-time. The Roman Senate is in session right now at its location in the block. Julius Caesar is being assassinated right now at its location in the block. The eruption of Vesuvius is burying Pompeii right now at its location in the block. This is not metaphor. In the block universe, these things are as real as anything happening around you right now. They exist at different coordinates in the four-dimensional structure, but existence is not conditional on coordinates. A point in space exists even if you are not there. A moment in time exists even if you are not then. But this has implications that go beyond nostalgia. Every person who has ever died still exists at their location in the block. Every child who died young still exists at every moment they were alive. Every relationship that ended still exists at the moments it was alive. Loss in the block universe is not what it seems. You have not lost the people who are gone. They are still there, at their location in the block. You cannot reach them, you cannot communicate with them, but they exist. This may be cold comfort or no comfort at all, because existence without experience, existence that cannot be visited or felt or shared, may not be the existence that matters to us. But it is existence nonetheless. Physics says so. And here is something even stranger. In the block universe, not only does the past exist, but the future exists too. The moment of your death exists. It is at a particular location in the block. You will reach it, but it is already there. You are, right now, in the sense that matters to physics, dead, at a particular location in the block. The you that exists at that location has no experience of existing, but it exists, just as you exist right now. The only difference between now and the moment of your death is the location in the block where your consciousness currently resides. The moment of your death is not in the future, it is in the block. It is as real as this moment. You just haven't reached it yet. We usually think of death as an ending. The block universe suggests it is more like a destination, a fixed coordinate in space-time, already existing, waiting at its location in the four-dimensional structure of reality. I do not know if this is comforting or terrifying. Probably it is both. Now I want to step back from the physics and think about what all of this means for how we live. If the block universe is right, if every moment exists permanently, if the past is not lost and the future is already real, does that change anything? Some people, when they first encounter the block universe, feel a kind of despair. If the future is already written, what is the point of trying? If free will is an illusion, if my choices are already fixed in the block, why bother choosing? But I think this response misunderstands what the block universe actually says. The block universe does not say your choices do not matter. It says your choices are already part of the block. They exist. They are real. They have effects on other locations in the block. The fact that your future choice exists in the block does not mean it was not genuinely your choice. It was your choice. That is why it exists the way it does in the block, rather than some other way. Think of it this way. A river carves a canyon over millions of years. The canyon exists. It is fixed. But the river genuinely carved it. The existence of the finished canyon does not mean the river didn't do the carving. Your life is carving its path through the block. The path exists, but you are genuinely carving it. And there is something beautiful in the permanence. Every act of kindness you have ever done is permanently real. Somewhere in the block, the moment you helped a stranger exists, unchanged and unchangeable forever. Every moment of real connection with another person exists permanently in the block. The conversations that mattered, the silences that said more than words, the laughter, the comfort, the love, all of it is real, all of it is there, all of it is permanent. The Buddhist philosopher Thich Nhat Hanh speaks of the present moment as containing everything. The past and the future are both present in this moment. This sounds mystical, but the block universe says something structurally similar. Every moment contains in its structure the traces of every other moment. The universe is not a sequence, it is a whole. And perhaps the most profound implication is this: if every moment is equally real, if no moment is more present than any other from the perspective of physics, then the present moment, this one, right now, is not privileged. But that means it is not more fleeting than any other moment either. This moment is not rushing away into the past. It is taking its permanent place in the block. It is becoming fixed, eternal, real. The moments you are living are not disappearing. They are being inscribed permanently into the fabric of space-time. You are not losing this moment. You are creating it, and it will be there forever. So, what have we established? Time as you experience it, the flowing river of past, present, and future, does not correspond to any fundamental feature of the universe. The present moment is not special. Relativity shows that different observers have different presents, and there is no fact of the matter about whose present is the real one. The past is not gone. The block universe says every moment that has ever occurred is permanently, physically real at its location in space-time. The future is not open. It exists in the block, already there, waiting for your consciousness to arrive at its coordinates. The flow of time is not a feature of the universe. It is a feature of consciousness, constructed by the brain from the information content of memories, creating the experience of motion through a static structure. The deepest equations of physics have no time variable. Time is not fundamental. It is emergent. It arises from something deeper, something we do not yet fully understand. And the direction of time, the arrow that points from past to future, is a consequence of entropy, which is a consequence of the particular low entropy state in which our universe began, which is something we cannot yet explain. Time is the most intimate feature of your experience, and it is the thing we understand least about reality. But here is what I want you to take away. The moments of your life are real. They are permanently real. They exist in the block, and they will not decay or fade or be forgotten by the universe. The people you love are real. At every moment they were alive. The connections you have made are real. The experiences you have had are real. And this moment, right now, is real. More real than you may have believed. Not because it is the present. There is no objective present, but because it exists, because it is happening, because it is being inscribed right now into the permanent four-dimensional structure of a universe that does not forget. You are not racing against time. You are creating eternity, one moment at a time.